Here we are asked to solve an equation, and the equation is in what we call a proportionate form, or how we have a ratio equals a ratio, and this is called a proportion. And the famous technique to use to solve this is called cross multiplication. And cross multiplication isn't actually a trick, it's just multiplying both sides by appropriate constants in order to, for lack of a better word, clear the fractions. So for most intents and purposes, you can remember it as if you happen to have A over B equals C over D, then you know for a fact that AD is going to be equal to BC. BC. You can verify this fairly quickly with just some numbers like fractions you might enjoy, like 1/2 and 2/4. But as the reason why we call it cross multiplication is because if we have a fraction equals a fraction, or a ratio is equal to a ratio, you can think of a line going through like that and creating an A times D on the left-hand side, and a line coming through like that and kind of creating a BC on the right-hand side. And so it looks like a cross, and what you're doing is multiplying. So I think that's what motivated the name cross multiplication. So in our problem, we have an 21 over x equals 30 over x minus 3. So if we use the technique of cross multiplication and cross this way first, we will see that there is a 21 being multiplied by an x minus 3 on one side, and on the other side we're getting an x multiplied by a 30, or 30x. And so what this effectively does is it takes the fraction equation, the equation that has fractions in it, and it turns it into a nice linear equation that sits on one line. So in this particular problem now we can start to use our previous techniques for solving linear equations. So for example, in the first stage you might use the distributive property and distribute the 21 through on the x minus 3. This of course would yield 21 times x, which is 21x, connector of a subtraction sign, and 21 times 3, which is 63. We didn't touch the right-hand side yet, so I'll put equals 30x. Now, we would wish to isolate our variable, right? Unwrap our present. So the fact that there's a 30x on the right and there's a 21x on the left might lead you to think about subtracting 21x so that we can isolate the variable, or collect like terms. So what does this effectively do? Well, 21x minus 21x would cancel each other out nicely, and all that would remain on the left would be the number negative 63. On the right-hand side, you would have a 30x subtracted by a 21x, and 30 minus 21 is just 9, so that creates a 9x. We're that much closer to unwrapping the present. Now we have a 9 times x. So let's divide the left and the right by the number 9. The reason why we're dividing by 9 is so that the 9s will cancel out, right? 9 divided by 9 is just 1, so there's no need to write it in. And all that would remain on the right-hand side is the number x. On the left-hand side, we have negative 63 divided by 9, and that's the number negative 7. So, the final answer to the problem, if we write it in a more sort of polite form, would be x is equal to negative 7. X is equal to negative 7. You can check this number as an answer by replacing it into the initial equation.